Okay, can you hear me?
Yes, yes.
Okay, thank you. So now exercises number 2. So charges of magnitude 100 microcoulomb, each are located in vacuum at the coordinates A, B, and C. So okay, the problem number 2. So we have such kind of situations. So each sides are equal. Okay, so this edge is A, this one is B, and this one is C. We have the 3 charges which are the Q, Q, Q. So here negative Q, there is positive Q, here also positive Q. Positive, positive, and negative. So Q is equal to 100 microcoulomb. Means what? So micro means the 10 to the minus 6, right? It means that the 100 multiplied 10 to the minus 6 coulomb. It means 10 to the minus 4 coulomb for each charge. Okay? So these 2 charges are positive. It means what? This charge is repelled this one in this direction. Okay, so this one is positive and this one is negative. It means what? These charges attract these ones here, or these charges attract this one in this direction. Okay, this one and this one. So we can calculate the total force at the point C. Point C. So total force directed in this direction. Because I hope that you know in mathematics, in math, if there is the 2 vectors directed like this, the first one is, let's say, this one is F, and this one also F, and it's directed in this direction, F, and you should find total force in this direction. Let's say on F1 and F2, here is F. Okay? And as you can see here, the angle is 60 degrees. 60 degrees. And look, if the 2 forces are equals, so the angle this also equals to 60 degrees, right? Okay. Okay. So the distance between the 2 charges is 4 meters, and here also 4 meters, here also 4 meters. So first of all, I should find the force FCA and FCB. After that, I should calculate the force F. Okay. So, what about the force of the FCA? FCA is equal to K, as usual, multiplied by this Q, multiplied by this Q, is Q squared, okay? Divided by this distance. So distance is the 4 meters, and 4 square is equal to 16, and the Q is equal to 10 to the minus 4 coulomb, and 10 to the minus 4 square is equals to 10 to the minus 8 divided by 16. 16. Here also K is equal to 9 multiplied 10 to the 9. Okay, so 10 to the minus 8 multiplied 10 to the 9, it means 10. 10. So 10 multiplied by 9, 90. 90 divided by 16. Let me calculate. So 90 divided by 16, 5.6. 5.62 newtons in this force is equal to 5.6. Okay, what about this force? So this force is FCB. Okay, FCB. Okay, again multiplied by Q1, Q2 divided by R squared. So Q1 in model, Q1 is the positive, okay? So it means the 10 to the minus 4 multiplied the also 10 to the minus 4 multiplied the K. K is equal to 9. 10 to the 9 divided by 16. And it's also is equal to 5.62 newtons. So what about this vector? This vector. If here the 60 degree, here also 60 degree, what about these ones? So we have the picture. These ones. So this angle is equal to 60, and this one is also equal to 60. It means what? If here also 5.62 newtons, here also 5.62 newtons, here also 5.62 newtons. What? Why? First of all, you should find this angle. This angle. So this one is the triangle, right? So if this is the triangle, so if the 60 plus 60 plus alpha is equal to what? 180. It means that 120 plus alpha is equal to 180. Alpha is 60 degrees. Here is also 60 degrees. It means that the F is also is equals to 5.62 newtons. So F is equal to 5.62 newtons. Answer is 5.62 newtons. So our answer is correct, and we should go on the next problem. Okay. Problem number 3. Problem number 3. And be careful, is the problem number 3. This kind of the problems should be in exam. Okay, now I can clean this part. So problem number 3. It's very important because such kind of problems should be in exam. Okay, so we have again two positive charges. And magnitude of the two charges is 10 microcoulomb. Okay. So let's say this one is the real part, this is the imaginary part. So Q1 is here, Q1 positive, and Q2 is positive here. And the position of Q1 is what? So here is 1, 2, the real part is 2, the imaginary part is 1, 2, 3, 4, 5. It means what? Oh. Here is 2, this is meter, okay, and here is 5. What about the Q2? So here 1, 2, 3, 4, 5, and 2. So 5 in real part, and 2 is in imaginary part. Okay, and here the origin, initial point. So let's say this one is R1, this one is R2. So we should find the R here. So R1 is equal to what? R1 vector is equal to what? So if we want to find this distance, we should find this point, and we should find this point, okay? Then we can subtract this one to this one, okay? So this one is equal to 2 real point, and this one is imaginary one, means the 5i. Okay, so you can subtract this one to this one. This one is the 0. Real part also 0. The imaginary part also 0. It means that 0 plus 0i. Okay. If you subtract this number to this number, you can subtract the real part to real part, imaginary part to imaginary part. Okay. So 2 minus 0, it means it's equal to 2. Then 5 minus 0, also 5. So 2 plus 5j. The R1 is equal to 2 plus 5j. Okay, what about the R2? R2. So this point is equal to 5 plus 2j, 2i. So 5 plus 2i minus origin. It means 0 plus 0i. So we can subtract the 5 to 0, also 5. So 2i minus 0i, 2i again. So this distance is equal to 5 plus 2i. Then we must find this distance. Okay, so this r is equal to what? So R2 is equal to R plus R1. So R is equal to R2 minus R1. So R is equal to R2 minus R1. So R2 is equal to 5 plus 2i minus 2 plus 5i. So 5 minus 2, 3. So 2 minus 5, it's a minus 3. But here also minus is the plus 3j. Okay. Okay. So now we should calculate the unit vector. Unit vector of R. Unit vector of R is equal to unit vector of R is equals to what? Is equal to R divided by absolute value of R. Okay, so R is equal to this one, 3 plus 3i divided by the absolute value of R. So we should calculate the absolute value of R. So absolute value of R is equal to this one, the square root of real part squared plus imaginary part squared. So it means 3 squared plus 3 squared. So 9 plus 9, 18. Square root of 18 is what? Square root of 18, let me calculate. So square root of 18 is equal to 4.24. Okay. So now we can calculate easily the unit vector. Okay. So we should put here the 4.24. Then so 3 divided by 4.24. 3 divided by 4.24 is equal to 0.7. So 0.7 plus 0.75. Okay, this is the unit vector. Understand? I hope you understand this point. Okay. So now we calculate the force between the two charges. Okay. So F, it's not visible for you. Now it's okay. So F is equal to K multiply Q1 and Q2 divided by R squared and R unit vector. Okay. This is all model. Okay. So K can you calculate this one now? So K is equal to 9 multiplied 10 to the 9 multiply Q1 and Q2. So Q1 and Q2, they are equals and 10 microcoulomb. Each of them 10 microcoulomb. It means that 10 multiplied 10 to the minus 6 and is equal to 10 to the minus 5. Okay? So 10 to the minus 5 multiplied 10 to the minus 5 is equal to 10 to the negative 10. Okay? Divided by r squared. Divide by r squared. What about the absolute value of this one? Is the absolute value of 10 squared. Okay, absolute value of r 10 squared. So we can calculate the absolute value of this one. This one is equals to 4.24. Okay, so 4.24 squared is equals to 18. Here. 3 squared plus 3 squared, 9 plus 9 is 18. So here also 18 because of square here. Multiply by unit vector of r is equal to 0.7 plus 0.7 I. Okay. So this one is 10 to the 9 multiply 10 to the minus 10. It means 0.1 or 10 to the minus 1. So 9 multiply 10 to the minus 1, it means 0.9. 0.9 divided by 18, 0.05. Okay? Okay, so okay, so 9 divided by 18 multiply minus 1, 0.7, 0.7 I. Okay. Okay, so this one is equal to 0.5 and here 0.1 is equal to 0.05. Multiply 0.7 plus 0.7 I. So you should multiply 0.7 to 0.05. 0.05 is equal to 0.0035. 0.035 plus 0.035 I. Okay, understand? If you understand this one, I can give you another problem, okay? Like this one. Can you solve now, guys? Vladislav, can you solve now? No answer. Okay. Okay. Guys, we have one problem. If we subtract R2 minus R1 here, 5 plus 2i here, 2 plus 5i. So 5 minus 2, 3. 2i minus 5i is not positive, negative 3j. And here also no positive, negative 3i. Here also negative 0.7i. And here also negative, here also negative, negative, and our answer is 0.035 minus 0.035 I newtons. Now it's correct. Sorry for the mistake, okay, but it's not okay. The next one. There should be an exam also. So we have again this kind of situation. We can clean for this one. If we have again two charges, two positive charges, Q1 and Q2. So 1, 2, 1, 2, 3, 7, 3. So here is 2, 7, and here is 3. The Q1 and Q2, they are equals to each other, and also 10 microcoulombs. You should calculate the force between the two charges. So can you calculate now, guys? Can you hear me?
Yes, yes.
Can you calculate this one?
We are trying.
Okay. Is it visible for you?
Yes.
So here is 2, here is 7, here is 3. So this is Q1 and Q2. So Q1 and Q2 are equal and is equal to 10 microcoulomb. So you can calculate the force between the two charges. So such kind of problems should be in exam. If now we can solve this kind of exercises, I hope that you pass the exam in this course. So now I am coming, okay? Okay, this one is home task for you guys, and we have one example here. Electric force in hydrogen. So calculate the magnitude of the electrostatic force of attraction exerted by the proton on the electron. So we have the two charges, which are the electron and proton. The charge are equals, and Q is equals to 1.6 multiplied 10 to the minus 19 Coulomb, but the electron is negative charge. So electron's charge is equal to negative 1.6 multiplied 10 to the minus 19 Coulomb. And here the distance between the two charges, which is the 5.3 multiplied 10 to the 11 meters. So you can calculate the force between the two charges in scalar form. It's very easy. So the force is equal to K, which is the 9 multiplied 10 to the 9 Newton meter square per Coulomb square, multiplied the module, the absolute value of the two charges. So 1.6 multiplied 10 to the 19 multiply again 1.6 multiply 10 to the minus 19 divided by 5.3 multiply 10 to the 11 square. Then you can get the answer. Answer must be equal 8.2 multiplied 10 to the minus 8 newtons. Okay.
The answer is 0.9.
Which one? You
This,
mean
the yes, on the board.
on the board?
Yeah.
Answer is 0.036 newtons.
Okay.
Now we can calculate it together. Okay. So we first of all we should find the distance r1, then r2. So r1 is equals to, this point means what? 2 plus 3j, right? 2 plus 3j minus this point. I mean the initial point of r1. So if you calculate the distance of the distance, you can subtract this point to this point. Okay, so 2 plus 3j minus 0.0j. It means that 2 minus 0 is 2 plus 3j, this one. Okay, what about the R2? This is the vector. This is also vector. R2 is equal to 7 plus 3j minus 0 plus 0j. It means 7 minus 0. 7 plus 3j. And what about the distance between the two charges? R. R is equals to R2 minus R1. Okay, so R2 is equal to 7 plus 3j, 7 plus 3j minus 2 plus 3j again. So 7 minus 2 is equal to 5. 3j minus 3j is 0j. So only 5. Okay, only 5. What about the unit vector of R? So unit vector of R is equal to, so R divided by absolute value of R. R is equals to 5 minus 0j, and absolute value of R is equal to 5 squared plus the 0 square and the square root of. Okay, so it means that the square root of the 5 square means that 25, 0 square is 0. So 5 divided by 5, 1. 1. So the unit vector of R is 1. So now we can calculate the force between the two charges. F is equal to K, 9 multiplied 10 to the 9, and Q1 and Q2. So Q1, Q2 is equal to 10 microcoulomb. It means that 10 to the minus 10 divided by R squared. R is equals to 5 plus 0J. So 5 plus 0J absolute value square multiplied by unit vector is equal to 1. 1. Okay, so 9, 10 to the 9 multiplied minus 10 divided by 5 squared is 25 multiplied by 1. It means that what? So 0.9, sorry, 9 multiplied 0.1 is 0.9 divided by 25. So 0.9 divided by 25, let me calculate, 0.9 divided by 25 is equal to 0.036 newtons. Okay. Understand now?
Yeah.
Okay. Thank you very much for attention. And our last problem is the following. Calculate the electrostatic force of attraction exerted by the proton on the electron. We have the two charges which are electron and proton. Okay. Now, last problem. Okay. So we have the two charges. This is the positive, it means the proton, and here is the electronegative charge, electron. So these two charges attract each other. So, and the distance between the two charges is equal to R 5.3 multiplied the 10 to the 11 meters. So I think you know the charge of the electron and proton. So they are equals every time, and the charge of the proton is equal to 1.6 multiplied 10 to the 19 coulomb, and the charge of the electron is equal to negative 1.6 multiplied 10 to the 19 coulomb. They are equals, but the electron is negative. Proton is positive always. So the force between the two charges is equal to K multiplied Q1, Q2 divided by R squared. So K is equals to 9 to the 10 to the 9 multiplied Q1, 1.6, Q2 also 1.6, multiplied 10 to the minus 19, it means 10 to the minus 38, divided by R squared. R is equal to 5.3 multiplied 10 to the 11. It means 5.3 squared 10 to the 22 negative. So I should calculate this one now. So 9 multiplied by 1.6 multiplied by 1.6 divided by 5.3 divided by 5.3, 0.82. So 0.82. So it means the 9 minus 38, it means minus 29. If this one is going to move the numerator, it means the plus 22. So plus 22 minus 29, it means the 10 to the minus 7 newtons. So 0.82 10 to the minus 9 or 8.2 multiplied 10 to the minus 8 or 8.2 10 to the negative 8 newton or 82 nano newton. Why nano? So nano newtons means 10 to the minus 9 newton. So answer is 8.2 multiplied 10 to the minus 8 newtons. Okay. Now we are going to finish. We are finished. We have finished our lesson now. So do you have any question?
Now all this understandable.
Okay, thank you very much. And I hope that you will come to next lesson in the alt center, okay?
Okay.
And you know that we have such kind of problems with the connectivity and so on, okay? So I'm going to wait you next Friday here. Thank you very much. Bye bye, guys.
Bye, guys. Bye. Thank you.
Bye bye. See you.
Teacher, also you can you send the theme of our today's lecture?
Yes, yes, of course. I will send you the PowerPoint version also. Okay. Bye bye. See you.
Bye. See you.